again, Avon High School ACE College Algebra 2 student. Mr. Record here, and we are going to continue our discussion over our section 12.3, which predominantly covers dealing with vertical asymptotes and point discontinuities. And the purpose of this video is to highlight more upon the point discontinuity aspect, and we'll do that with example 2 if you're following along with your notes. So if you remember in example 1, we had filled out this particular box that related to the graphs that were on the second page of your notes from section 12.3. You recall we had a graph of f, g, h of x, and p of x. Well, in example 2, we're asked to do a few more things in the way of filling out this particular box. So we'll start with part A here. We have the function that was represented by the graph of f of x, and we're asked to rewrite the function in simplified form. Well, I know you may have already done that a moment ago if you watched video from example 1, but we'll do that once again here and do our factoring. It's good practice nonetheless. And I'm going to write this up here. So if we do the factoring, we end up getting 2x and x. And then I think we decided that we want to put the minus 3 at that spot and the plus 1 at that spot. So that would ensure that we would get the minus 5x in the middle. And again, we have the minus 3 and the plus 2 here. So we find out that the x minus 3's cancel. So the simplified version would be 2x plus 1 over x plus 2. Now, when you fill out the rest of your notes, there's nothing wrong if you just go back and look at what you did in example 1 and basically replicated what you see in that third column. But you want to definitely put those same expressions in this first column with example 2 so that you can move on with the activity. So it says, at what x value does the graph have a point discontinuity? Well, hopefully we remember from the other video that wherever the denominator canceled, that was where the x value has that whole or point discontinuity. So in this case, we knew that that occurred at x equal 3. Once again, from the graph, we can see that that's where this hole is occurring, at x equal 3. Well, then this next question says, find the value of the simplified form of the function when x is the value of the point discontinuity. And a lot of times students get kind of confused about what this really means. And what this means is you would take your answer from the first column. So in this case, it would be the 2x plus 1 over the x plus 2. And we would evaluate that such that x equals 3. Now, the notation that I'm using there it's a nice notation that I think is pretty clear to indicate what we're trying to do. I don't think what you want to do is say, hey, I'm going to evaluate the function for f of 3, because if you do that, we're talking about going into the original version of the function where 3 is considered to be a restricted value. We're talking about plugging this into something that's somewhat equivalent to the function. Not everywhere, of course. Of course, not equivalent at that point of discontinuity. So we won't use f of x notation per se. So if I plug 3 in, it's pretty clear that I get 7 on top, and I would get 5 on bottom. And then when I basically put these last two columns together, that allows me to answer the fourth column, what were the coordinates of the whole. So we would say 3 comma 7/5. So if I run right back to the graph just to verify, we knew that 3 was the x coordinate, and lo and behold, 1 2/5, 7/5 is the y coordinate, and that's exactly what we have here. So basically, you would want to finish up the rest of these rows for G, H, and P by simply doing the same thing that we did in part A, and of course you have the ability to check the answers because the coordinates of the whole was provided for each of those problems. So this was a quick short little video, the ones I know you kind of like, and this would pretty much round out the notes as there are only 2 examples from section 12.3. Anyway, I hope this helps, and I'll see you at the next video.